So, so, ladies and gentlemen, you are all cordially welcome to a topic on regression. Regression is an important topic. Okay? Regression looks at relationship among variables. For example, what is the relationship between blood pressure and your weight? Some people think that when you're increasing your weight, the likelihood of your blood pressure going up is high. But are there other factors involved, like your age, stress, diet, exercise, apart from the weight? How do you control these factors? How do you use them to predict the next blood pressure? What are the underlying assumptions? Okay, that's the essence of correlation and regression. So I'm going to share with you quickly what correlation is about. Correlation looks at the interrelationship or the relationship between two variables. Who can give me another word for correlation? What do you think? Correlation, you can type it there. What is another word for correlation that you have in mind? One word for correlation can talk about linkage. We've already spoken about relationship, link and linkage. What other word comes to your mind when we talk about correlation? Correlation. Okay. Okay, let me see. Somebody has indicated association. Very good. Association is another fine word. Okay. Nexus, relationship. Good. So there's a correlation that can be strong or weak. For example, what do you think is a relationship between a brother and a sister? Okay, is it strong or weak, relatively speaking? A brother and a sister, is it strong or weak? Anyway, I like your connection and dependence. Very good. The relationship between a brother and a sister is strong compared to your relationship between cousins, that is weak. Okay, so a correlation can be strong or weak. It can also be positive or negative. For example, what do you think is a correlation between consumption and income? Positive or negative? Consumption and income. Is it positive or negative? Consumption and income. Be used to typing some. Okay. Be used to typing. Don't say that your colleagues are going to type. So you won't type anything today. Okay. That is already a dead motion. Okay. So consumption and income, that is positive. Very good. What about price and quantity demanded? Price and quantity demanded, that is negative. Okay. Price and quantity demanded is negative. Now, look at the relationship on your screen. Is it positive or negative? What you see on your screen. Okay. Is it positive or is negative? It's negative, yes. No, it's not negative. The relationship on your screen is positive because you can see that they are moving in the same direction. So that is positive. You are moving in the same direction. Now, what about this second one? Is it positive or negative? It's negative. This second one is negative because they are moving in the same direction. So please note, a positive relationship move in the same direction. A negative relationship move in the opposite direction. Okay. All right. But you see, using a picture is not enough. We need to know the actual amount. For example, if you tell me that the relationship between you and your spouse is negative, or let's use positive, because you want to be positive. The relationship between you and your spouse is positive. Somebody will not know the strength of the relationship. It is one thing saying the relationship, and another thing speaking about the strength of the relationship. Because if somebody's strength of the relationship is 80% and another is 95%, I'm sure you will agree that they are different strengths. So a numerical quantifiable value is important to determine how strong the relationship is. And this statistic for doing that is known as a correlation coefficient. Specifically, it's known as a Pearson's product moment correlation coefficient. It is between -1 and +1. Okay. The more negative it is moving towards -1. The more positive it is moving towards +1. The absolute value is what is important. It tells you the strength, not the sign. Not the sign. It is the absolute value that tells you the strength of the relationship. Talking about this, let me just give you a quick trick. I have a variable called A, and then I have a variable called B. The A is negative 0.92. The B is 0.89. Which of them shows a strong relationship? Is it A or B? Type it for me. Which of them shows a strong relationship? Is it A or B? Some say A, some say B, some say A, some say B, some say A, some say B. This is interesting. This is interesting because what it means is that some of you did not understand. The one with a strong relationship, is A. A shows a strong relationship. I just told you that the sign does not matter. When we are talking about the strength of the relationship, the sign of whether it's negative or positive is irrelevant. You use the absolute value in your mind. The sign is just telling you the magnitude, okay, the direction, that's it. But it does not tell you the strength, the depth of the relationship. And the depth of the relationship is determined by the absolute value. So a stronger relationship is the 0.92 in absolute term, negative 0.92. Okay. Now, let's move on. I want you to look at this relationship. Okay. I want you to look at this relationship very carefully. I'm going to ask you something quickly. Now, what is the relationship? Is it positive or negative or something else? You have A, you have B, you have C, and then you have D. A, what is the relationship between X and Y? A, what is the relationship between X and Y? What is the relationship between X and Y? Let me know. It's positive. There's no doubt about that. Lucky, that was a good answer. It's positive. Emmanuel, that was a good answer. It's positive. Okay, Richard, that was a good answer. It's positive. Now, what about B? B. Is it positive or negative? B. Pop or net? It's negative. There's no doubt about that. Shows a negative relationship between X and Y. Now, why do we say so? Watch it. As you are from the zero, okay, suppose you start from the zero, okay, and then you are moving towards X. You are moving, okay, you are moving. As you are moving, something is happening, okay, something is happening. You can see that Y is falling and X is increasing. Watch it. Y is falling and then X is increasing as you move along. Okay, that's why we say when one is falling, the other is increasing. That's a negative relationship. Okay, one is falling, the other is increasing. So you see that one is increasing, the other is falling. That is a negative relationship. And that is what we are talking about. Now look at the C. Okay, the C. What relationship do you think that is? What relationship do you think the C is? What relationship is the C? Now, if you don't take care, you might say that it is negapos. It's negapos. It's not negapos. The C is showing a quadratic relationship. Okay, it exhibits a relationship that rises and then falls. So it rises to a point, gets to a point, and then it starts to go down. That is, okay, a quadratic relationship. And of course, this one is quite tricky. It's a logistic relationship. It's a relationship that shows that as X is rising, Y is rising at an increasing rate. So this is just to show you some of the existing relationship that one can actually think about. Okay? Some of the existing relationship that one can actually think about. All right. So let's go to regression. There's a simple regression, and then there's a multiple regression. A simple regression shows the relationship between one independent variable and a dependent variable. Okay, so I want you to look at this. The independent variable is the the X here. The X is an independent variable. Okay, the independent variable is the X, and I'm going to tell you what it does. The dependent variable is the y. The dependent variable, that is the y. The dependent variable is the y. Now, what is the difference between the independent variable x and the dependent variable y? The independent variable has other names. And these are some of the other names of the independent variable. If you check the slides, the independent variable is also called a predictor or an explanatory variable. This is very important, and I want you to note that. It's a predictor or an explanatory variable. Now, the dependent variable is also known as outcome, dependent, explain, response. Okay. Now, I want you to know this very important. This is it. Put this down. Write this down. The independent variable reacts, okay, causes the dependent variable to behave in the direction of the independent variable. So the dependent variable or the outcome behaves according to the behavior of the independent variable. So the independent variable causes the dependent variable to behave the way it's behaving. Okay. Now that is in a simple regression. In a simple regression, the independent variable is just one. That's it. It's just one. But in a multiple regression, the independent variables are many. And in this case, because there are many, each one of them is trying. Each one is trying to behave in a certain way to affect the dependent variable. Each one is trying. The dependent variable is a y. The dependent variable is always on the left-hand side. Okay. And the independent variables are the letters, not the beta parameters. I'll come back to that one. The independent variable are the letters, the A, the B, the C, the D, the E. These are the independent variables. And these independent variables actually behave in a certain way. Not the same, but in different ways. But as they are behaving, they will affect the behavior of the dependent variable. They will affect the behavior. Okay. Now, what are the beta parameters? This beta 1, beta 0, beta 1, beta 2, beta 3, beta 4. These are called coefficients when they have been estimated. Coefficient. So beta 1 is a coefficient. Beta 2 is a coefficient. Beta 3 is a coefficient. What did they do? Well, if you can see, each one of them is attached to an independent variable. So an independent variable, say A, says that I can affect Y in a certain way. That's what A is saying. I can affect Y in a certain way. But you know what's funny, eh? Now the question is by how much? That is what the beta 1 is talking about. By how much can you affect Y? So the beta parameters tell you by how much each independent variable can affect the dependent variable. And please put that down. Okay, if you're not used to writing, be used to writing. It's a very powerful way of learning. Writing is a wonderful way of learning. Okay. So the beta parameters, they tell you by how much each independent variable affects the dependent variable. So D can say that I affect Y. C can say I affect Y. Okay, everybody is claiming that I can affect Y. Now the question is by how much? So let's say that C affect Y by 50. Okay, so the value here is 50C. And then the value here is 47D. Okay, so if this one is 47D, now you can tell which of them affect Y by more, isn't it? So now it's not a matter of I can affect Y, I can affect Y, but by how much? Now you can see that C can affect Y by more than D can affect Y, using what? The beta parameters. So the beta parameters tell you by how much each independent variable affects the dependent variable. Now that leaves us with the last one, which is the error term. The error term. There are 7 different names for this error term, and I want you to note them. The UI is the error term. Sometimes we represent it by epsilon I, like this. Okay? It doesn't matter. Okay? I'll be using those two interchangeably. So what is the UI? Now, first of all, these are the factors that are trying to explain the dependent variable. Okay? That's why they are called explanatory. That's why they are called explanatory. So that means that there are some factors that do not help you to explain the dependent variable. They are here. These are the unexplained part. So what is that? So the UI, we call it the error term. We sometimes call it a disturbance term. We call it the stochastic noise, the random noise, the unobserved heterogeneity, the idiosyncratic error, the unsystematic error, the residual. I'm giving you some strange names, but don't worry, you got to know them. Okay, so these are some of the names, but the common one is the error term. What does it do? The error term captures all other factors that could also have affected the dependent variable, but are not yet available. In other words, they are hidden. They are invisible, but behind the scenes, they are disturbing this original relationship. They're disturbing the original explanatory variables and how they affect the dependent variable. They are errors, they are mistakes, they are residuals, they are disturbance. So for example, it can be that the relationship between you and your spouse is very strong. And it can be affected by sex, it can be affected by love, it can be affected by income, in-laws. But there could be other factors too that can disturb the relationship, like side chicks, okay? Like, football, like something else. So those factors that you could not remember, these are latent, they are hidden, and they can affect the relationship between the dependent variable and the independent variable. Okay, so that's what we call the error term, okay? The error term. I'm going to take a practical example for us all to capture it. Let's take a real life situation. Let's say your salary, and I'm representing that by wage, okay? Your salary, you all agree with me that your salary is affected by your education. You all agree? If you agree, type yes, okay? Your salary is affected by your education, okay? Now, your salary is also affected by your experience. You agree with that? Because the level of experience will determine how much goes into your bank account at the end of the month. But it's also affected by your position and your ability. You may have a special ability which the organization will be paying you for. Now, the UI here include other factors that can affect your salary, your wage. But these other factors have not been captured yet. Who can give me a reasonable, a relevant, their factor must be relevant. Okay, who can give me a relevant other factor that can also affect our wage, which hasn't been captured yet? And please, it must be relevant. Okay, so type one factor, let me see. Which factor can affect the wage but hasn't been captured here? It must be relevant. Okay, now your status goes with the position. So I love the first guy. Okay, Sanya, your answer is excellent. Tax is one of them. Okay, what else? Okay, a membership of a union, excellent. Unionism, okay, that is good. Please, whom you know is irrelevant. Patriotism. The type of industry is important. Okay, the type of industry, okay, which is the risk factor of the industry. Okay, minimum wage is out. Performance appraiser is out. Location is important. Good. Location is important. Very good. Very good. Okay. Look at somebody, family size. This is very funny. Your family size is going to determine your wage. Who does that? Okay. We are not in old times. Okay. We are in a real life situation. Okay. Now, the country you live in is the same as the location somebody mentioned. Okay. But I guess this is it. Okay. These are the things that can affect your wage. Okay. Now let's go to another thing. Let's go to another thing. Okay. Another thing that we can establish a relationship. Now look at the blood pressure. Blood pressure. The blood pressure of a person is affected by the age. We all know that. It's also affected by the person's weight. We can establish that. By the stress, by the pulse. What other factors can affect blood pressure, which hasn't been captured here, but is inside this error term? Please, nobody should mention broken heart. Nobody should mention broken heart. Okay. When you break your heart one time, it's not a factor. Okay. All right. So what other factors can affect blood pressure? Your diet. I'll buy diet. I'll buy it diet. And every other thing that goes into diet. So let's call it medication, all of them. I'll buy exercise. Very good. Excellent. Christopher, exercise. Okay. Genetic. That is family history. Genetic. That's also very good. What other factors? Okay. Diet, exercise, genetic. Okay. Somebody mentioned something. I want the person to come back. Stress is already here. Matilda, how can you mention stress when it's already here? Right in front of your eyes. Okay. Okay. Hereditary, genetic, that's very good. What? There's something else that can affect the blood pressure. Forget about lifestyle. You can't even measure it. Okay. Everything here is lifestyle. Okay. There's something which is other diseases. Other diseases can also lead to blood pressure. But there's something, the woman should know about this next thing. Okay. The woman, you should know about this other thing. It can cause blood pressure. Financial status should not cause you blood pressure, please. We're talking about blood pressure, perineal. Yeah, excellent. Cynthia, that's good. That's the one I was looking for. Pregnancy. Okay, pregnancy can also cause blood pressure. In an exam situation, when I give you the equation, sometimes I will tell you to mention 4 other error terms, 4 other factors that can affect the dependent variable. So what I'm doing is I'm straightening your mental cerebral cortex to help you so that next time you can be able to. So it's important to think. And you can also see that I reject some of the things. And the fact that I reject some of the things means that you should talk about relevant factors. These are the main things that can lead to high blood pressure, which haven't been captured here. Okay. Which haven't been captured. Now let's go to another one. Okay. Another one. This is the last one. Okay. And this time, think about relevant factors for me. Now, quantity demanded of a good, and listen carefully because if you miss it, is affected by the price of the good. Okay, price. It's affected by the income of the person. It's affected by advertisements. Okay, and it's affected by whether the good is a complement or a substitute. Quantity demanded. If you did economics, you will know other factors of demand. Now, the rest are all captured in the error term. Who can give me another factor? Nobody should mention taste and preferences. Okay. I want to rule out that. What other factors can affect the demand of a commodity apart from the price, the income, advert, and whether the good is a substitute or complement? There are so many. Weather. So I'll buy, forget about any macroeconomic factor. Seasonality is one. Seasonality. What else? State of the economy, out. Market size, out. Technology, out. Quality, out. Okay, let's get relevant factors. Location is good. I'll buy that. Location. Okay, forget about brand. See, always ask yourself, can the thing be properly measured? Can it be measured? Okay, we are looking for factors that can be measured. Not factors that cannot be measured. Like if you talk about lifestyle, it's too broad. That's why I ruled out taste and preferences. So you have what? You can even have expected price, okay? Price expectation, not inflation, not a current inflation, but expected inflation. Okay, that's one. But there's something else. There's something, population, very good. Frank did well, population. Okay. Think. As you think, your brain expands its capacity beyond 10 quadrillions per second. Okay. Think and tell me some factors. Okay. You can talk about taxes and subsidies. Okay. Taxes and subsidies. Okay. It can also affect the demand of the commodity. So these are some of the factors. So now you can see all of these are what is known as the error term. The error term. Now, ladies and gentlemen, now let's go to the first bullet and compare it with this second bullet. Second bullet. I'm going to tell you something about these two. Very important. Now you can see that the first bullet has some things. There's some difference between the first bullet and then the second bullet. And I want somebody to tell me the difference. Who can tell me? The first one is known as specified regression model, and the last bullet is known as estimated regression equation. There are two main differences between these two. Who can tell me? Raise your hand and tell me if you can. There are two main differences, okay, between the specified regression model in bullet 1 and the estimated regression equation in bullet 2. The last bullet. What is the difference? Okay, so let me go to Abigail. Abigail, what do you have for us? What is the difference?
Okay, so I think their percentages had been attached to it. That is what I see.
Now tell me, which one are you talking about? Declare.
The last one.
The last one has a name. It's called estimated regression.
Estimated. Okay.
Well, she's saying it, but she didn't really specify well. There's something else. There's something else. Okay, Christopher, let's go to Christopher. Christopher, what is the difference between the first estimate, the first is specified model and the last is estimated equation? What is the difference? What is the difference between the two? Yeah, Christopher.
So the estimated model does not contain an error term, while the unspecified one contains an error term.
That's a first excellent answer. The estimated has no error term. The error term is gone to 0. Okay, that's the error. Stay there, don't go. Oh, I thought he's gone. Okay. I thought you were going to talk about another one. Estimated has no error. So look at the last version. There's no UI. There's no error term. Okay, Christopher, come back. Okay. Now, what is the second difference?
The estimated model has known parameters. The coefficients are known. While for the unspecified ones, the parameters or the coefficients are unknown.
Excellent, beautiful. You have answered everything. Excellent. Go and have a beautiful breakfast. That's how you actually learn. Okay, these are the people you want to associate yourself with, okay, and then befriend. Okay, because such people will elevate your mental gymnastics. Okay, please note these two differences. Note them. The specified model has beta parameters. The estimated equation has numerical coefficients. Write that down. You won't forget. Okay. The specified model has beta parameters. The estimated equation has numerical coefficients. 2, specified model has an error term. Estimated equation has no error term. So that's it. Now let's go back to regression problem. Now let's learn regression basics. Superlative, joy of regression. Before regression can happen, you got to make some assumptions. So what I'm going to show you here are the assumptions of regression. What are assumptions? Assumptions are certain things that have to be in place for certain things to work. Assumptions. There are certain things that must be in place for certain things to work. So you can't do a regression analysis. Remember, regression looks at the causal relationship between a dependent variable and multiple independent variables. Okay, that's a regression. And you can't do that unless you assume one, linearity. Linearity means that there is a linear relationship between the x and the y. Remember, the x is the independent variable. The y is a dependent variable. There's a linear relationship. Okay. In other words, what you are saying is that the relationship is not quadratic. It's not hexagonal. It's not a polyhedral. It is a linear relationship. Okay. So linear relationship means that it is constant in what is behaving. That's what it means. Linear, and this is important because sometimes some people don't get it. Okay. Linear comes from the word line. Okay. And the line doesn't mean that it has to be only moving together or moving separate. The line can be downward sloping, upward sloping, horizontally sloped, vertically sloped, or something, So it's all linear. Everything I've drawn here is linear. Okay? The only thing we are saying is that it shouldn't be curvy linear. It shouldn't be curvy linear. Okay. So that's the first assumption you have to understand. The second thing is normality. The errors, that UI that you saw, the errors should be normally distributed. The errors should be stochastic. That's another way of saying it. Okay? They should be normally distributed. They should be randomized. It shouldn't be like a certain systematic pattern. Okay? They should be normally distributed. It shouldn't be skewed to the left, skewed to the right. It should be normally distributed. Just like ages are usually normally distributed. Just like salaries are usually normally distributed. The next thing is homoscedasticity. Homoscedasticity. It is also about errors. It's also about errors. What it says is that see, let me tell you something about normality and homoscedasticity. Normality has to do with the measure of central tendency, the center. Okay. So when we say that the errors are normally distributed, what we mean is that they are within the center. They are within the center. Most of the errors are in the center. Okay. Now, but how are they different from each other? What is a gap? So normally in statistics, we talk about standard deviation. The standard deviation measures the dispersion, how variational, okay, how the individual observations vary from each other. And that is the principle of homoscedasticity. That is the principle of homoscedasticity. Homoscedasticity says that the variances between the errors, okay, must be constant. The variance should be constant. Okay, the variance should be constant. What does that mean? What does that mean when we say the variance should be constant? Okay, I'll give you a couple of examples. Okay, just watch the screen. Watch the screen. Okay, I'm going to give you an example. Okay, so look at this relationship between X and Y here. And I have these plots. Okay, I have the plots that are like this. Okay, I have plots that are like this, 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 that are like this. Okay, let's give another one. This is another one between X and Y. Okay, and I have plots that are like this. I have plots that are like that. I have plots that are like that. Okay. And then let's give the next one, which is X and Y. And I have plots that are, okay, plots that are like that. Okay, I have plots that are like that. I have plots that are like that. Okay, I have plots that are like that. 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 Okay. Now, just A, B, C. This is A, this is B, and this is C. Now, if the thing is homoscedastic, it means that the observation, there's a constant variance. There's a constant variance. Now, A, if it is not homoscedastic, it means that it is heteroscedastic. It means that the variances are not constant. So heteroscedastic means that non-constant variance. Okay. Now look at A. Is it homoscedastic or hetero? Homoscedastic or heteroscedastic? You know, this word is a beautiful word, a Greek word, so you have to pronounce it by swallowing saliva. Is it homo or hetero? A. Homo or hetero? It's homo. Very good. Okay. It's homo. It's homo. It's homoscedastic. It's homoscedastic. Okay, very good. What about B? B, is it homoscedastic or heteroscedastic? B, is it homo or hetero? B, is hetero. It's hetero because there's no specific pattern. Okay, you can't even identify the pattern. It's non-constant. And then what about C? C, is it homoscedastic or hetero? Homo or hetero? Oh, Pele, say some. Say some. You won't die. Say some. Okay. Is it homo or hetero? Is it homo or hetero? It's homo. Very good. It's homo. Very good. Richard, Enam, Jerome, Gifty, Matilda. Excellent. That's how you got to learn. These are the people you want to sit with in any adventure. Okay. Now let's go back. So Homoscedasticity is about the errors being constant. Normality is about the errors being stochastic, being in the center of the observation. Very good. Let's go to another assumption of regression. No autocorrelation. No autocorrelation. Okay. When you check my other videos, you see the definition of autocorrelation. Okay. No autocorrelation. Again, it's about the errors. Watch it. It's about the errors. So an error of this observation should be different from the error of the other observation. That's what it means. No autocorrelation. Autocorrelation means that they are serially correlated. They are serially correlated. In other words, they have an association. So let's say that one of the U's, we spoke about one of the UI. Okay, you remember the UI. Okay. And we have one UI, you have another one which is UJ, you have another one which is UK. And then all of these, they are related, highly related to each other. Then it means that it doesn't help you to be able to know. And if they are highly correlated with each other, they will affect the entire results. So one of the assumptions is that there should be no autocorrelation. They must be orthogonal. Orthogonal. Orthogonal means that we are not related. We are not related. Okay. So one day you can tell your spouse, hey, remember, we are not orthogonal. We are not orthogonal, which means we are very related. We are very related. Some of these words, you got to use them in your normal language for them to look appetizing. Oh, dear me. That's good. That's good. Let's move on. Okay. For your purpose, the very last assumption is multicollinearity. There must be no high multicollinearity. Now, let me define multicollinearity for you. Multicollinearity exists. And remember, the last word here is independent variables. Okay, the last word here is independent variables. That is the explanatory variables. So multicollinearity exists in a regression when two independent variables are so highly correlated. Okay, it exists in a multiple regression when two independent variables are so highly correlated that it's difficult to disentangle the partial effect. It's difficult to separate the partial effect of one from the other. It's difficult. It's hard to separate the partial effect of one from the other on the dependent variable. That is multicollinearity. I know somebody's going to say, repeat it again, but don't worry, you will remember it when you watch the video. Okay. So multicollinearity exists when two independent variables are so highly correlated that it becomes difficult to separate the partial effect of one from the other on the dependent variable. So let me give you an example. Let's say that your company has been sending people to go and do their master's degree. And after that, when they return to the company, their salaries are doubled. That's what happens. You've seen that happening for 3 years, but nothing is happening to you. And so you went back to your manager and told your manager that, look, I'm not happy. What is happening that is not happening to me? The manager said, oh, sorry, you didn't know? Anytime you are 5 years old, anytime you have 5 years experience in this company, anytime anybody is 5 years in this company, that person will be given a free scholarship to go do his master's. And when he returns, the person's income is doubled. Will you be happy now? Yeah, because you know you have how many more years? 2 years left. Okay. Now 2 years came. That means you have 5 years experience. And you were actually sent to go and do your master's. Truly, you came back and your salary was doubled. Question. What led to the increase in your salary? Was it the 5 years experience or it was a 2 years master's? Type your answer down, let me see. What led to the increase in your salary? Was it a 5 years experience or it was a 2 years master's? Which one? Was it a 5 years experience or it was a 2? Be careful with the answer that you're giving. Okay. Was it a 5 years experience? Everybody's writing both. Okay. Somebody says it's a 2 years. Somebody says it's a 2 years master. Now somebody is confused. He says it's a 5 years. I like that. Okay, ladies and gentlemen, this exercise was to help you to know that experience and education here are highly correlated. It cannot be both, it cannot be either. The confusion is because the two are highly intertwined with the conversation I just had with you. This is an example of multicollinearity. When two items are so intertwined that it's now difficult to separate them. That's multicollinearity. And so in a regression, when two variables are highly multicollinearity, you check it, you solve it. Sometimes if it is extreme, you remove one because the other becomes redundant. So you remove one from the system and you will not lose any information because they are all doing the same thing. The same thing. I normally have a story where I say that if a husband and a wife are in the house and then the husband goes to steal some company money on the 24th of December, and he's arraigned before the court because he was caught, and the wife is called to come and testify with an alibi. If the wife is one of those Jezebelic women and she says that, oh, the husband was not with me, the husband is doomed. Life in prison. But because we know the two of them are highly correlated, the best word to use here, they are multicollinear. Because the two of them are highly multicollinear, the wife will probably say that I was with my husband the whole day on the 24th of December. The whole day, we're in the same house. No problem. Now, the question is that because the wife is likely to say that, and he would likely be saying that, the jury is not going to be surprised because the two of them are highly correlated anyway. And so not bringing the wife into the court is the best. That is why in most court cases, you don't want a spouse to testify in some situations because it's either excellent or nothing at all. It's a typical example of multicollinearity. So when you go home today, tell your spouse, do you know that the two of us are highly multicollinear? If you don't take it, he will slap you and tell you are learning unnecessary things in school. But hey, when two individuals are highly connected to each other, we can say that they are highly multicollinear. Oh, that's it. We'll come back to this in the practical session. I want to just touch on dummy variables quickly because we'll meet that. What is a dummy? A dummy. When we say somebody is a dummy, it's like you are saying the person is stagnant, isn't it? The person is not changing. The person is static. A dummy, static, not changing, not moving. A dummy variable is a categorical variable. Do you remember numerical categorical? We did it in the first lecture. Numerical categorical. A dummy is a variable that cannot be in a kind of a numbers. You know, for example, if you take price, is in numbers, income is in numbers, ages is in numbers. It cannot be a dummy. But when you take gender, it's a dummy because there are two levels of gender. Watch the word I said. There are how many levels of gender? 2. Now, please, guys, tell me how many levels do we have for marital status? Reasonable level. Marital status, how many levels do we have? Even though I've not explained levels to you, I know you will understand what I mean by levels. Marital status, how many levels do we have? Oh, no, we don't have 2. Come on. Yeah, I like the answer Richmond gave. Okay. Richmond, your answer is good. Ajoa, your answer is good. Hey, goodness me, Jeremy, 13 levels. How do you explain 13 levels, Jeremy? Marital status, what are they? Jeremy, can you confess those 13 levels? Excellent answer by Richmond. Single, married, separated. No, I don't even like separated. Divorce, and then widowed. Take away the separated. The separated is not even, if you are separated, you are towards divorce. So these things we don't, it's like somebody says complicated. What is complicated? There's nothing complicated. You are either single or married, or divorced or widowed. It's one of them. Nothing else separated or complicated about it. Okay, so these are the 4 levels. So guys, do you see the difference? Now here is the point. A dummy variable will always, the number of dummy variables will always be 1 less than the number of levels. I want to repeat that. The number of dummy variables are always one less than the number of levels. So guys, if you have 4 levels, how many dummy variables would you have? Okay. If you have 4 levels, how many dummy variables would you have? 3, excellent. If you have 2 levels, how many dummy variables would you have? If you have 2 levels, how many dummy variables? 1, excellent, very good. Okay, that is why gender will have 1 dummy and 2 levels. That's it. A dummy variable is a categorical variable, it's a binary, 0 or 1 kind of variable. Okay, so now let me show you something. I will come back to this interpretation, even though it has a dummy. So look at this one. Return on asset is equal to 500 plus 20 profit plus 30 type. And this type is whether the company is a domestic or foreign. Now watch it. If it's a domestic, we give it a value of 1. If it is foreign, we give it a value of 0. So that's a typical example of a dummy. So in this case, the firm has how many levels? In this case, this firm, okay, how many levels does it have? A firm. This firm, how many levels does it have? And how many dummy does it have? Well, you can see the dummy is just type. So it's just 1 dummy. So Nanama, that's good. It has 2 levels, 1 dummy. Now the asset is a numerical variable, so it's not a dummy. It's not a dummy. Okay. I'm going to take a practical example. I think I've been able to do well to fly you through all of these dummy variables and everything. Okay. I've been able to do that for you. Now, what I want to do is to take a practical example called Brukutu Ventures. We are going to use this to understand correlation and regression right now, right here. Okay. So at this stage, I'm going to pause. If you have a question, you can ask. Okay, so what I want to do is to take this thing to look at the storyline. I want somebody to read it. Who can read the story for us? Who can read? Don't worry, we'll talk about the dummy very soon in this practical example. So don't worry, Rachel. Who can raise their hand and read? I want somebody to slowly read the package for us. Okay, Charles. Charles, okay. Read it.
Brukutu Ventures, a local gin distillery, is concerned about the demand for its favorite gin bitters. Demand in most of its retail shops has been hit hard due to new entrants into the market. Management is concerned and wants to determine which predictors better explain the quantity demanded of gin bitters, apart from the price of gin. Of the determinants of demand, the following were identified: price of complement, average real income of customers.
Okay, we are going to continue the reading. But before then, right here, who can tell me the dependent variable just from the story? Who can type what the dependent variable is right in the story? Or you can type, what is the dependent variable here? Looking at the storyline. So it's good. Quantity demand for gin. Okay. And it's been represented by Q. Okay. It's been represented by Q. And then the independent variables are being mentioned. Okay. The independent variables are being mentioned. Now, the independent variables, I'm going to show you them. So let me take you to the Excel and just show you the independent variable. So this is it. This is a dependent variable. This is a dependent variable. Q is the quantity demanded of gin bitters. P is a price of gin bitters. C is a complement price of gin. M is the average real income of the people. The average real income of the people. Okay. And then there are some things. Let's go back to the reading. And I want to explain it to you. There are some dummies that have been explained. You have been told that the quantity demanded of gin also depend on location. Now you can see that location is a dummy. How do we know? Because we're told that where LU is 1, if the location is urban, or 0 if it is rural. Okay. So location has been coded as 1 for urban and 0 for rural. Just as you would have coded 1 gender, 1 for male and 0 for female. So this is one of the independent variables. It's categorical. And so when you look at the actual name, let me take you back to the Excel. When you look at, even though it's been coded, the actual name of it is on the far right here. So look at this section here, location. Location. And you can see that the actual names have been written. Okay, the actual names have actually been written. And what are they? You have urban, rural. So it means that the first shop is urban. The second shop is urban. The third shop is rural. Okay, the next one is urban, then rural, then rural, then rural, and then all of that. So these are the actual names of the shops. So in other words, the quantity demanded depends on whether you are located in an urban area or in a rural area. Of course, the other dummy variable is that the quantity demanded also depends on the occupation. That's why you see here, the occupation of the people. So if the people, and there are 3 kinds of occupation that are here. You have teaching, okay, it's one of the occupation. You have fishing, is another occupation, okay. And then you have trading, which is also another occupation. So you can see that the first shop, the major occupation of the people are what? Teaching. The second shop, the major occupation are what? Fishing. The third shop, teaching. The fourth one, they are fishers. The fifth one, they are traders. Okay. And that is all in the story and in the preamble that we have. We were told that the dominant occupation are teaching, fishing, and trading. And we are told that OT, so we are now going, we can choose to code these names. OT is 1 if the occupation is teaching. OTR is 1 if the occupation is trading. But watch carefully, there was nothing called for fishing. There's nothing for fishing. But you see, it said that if the occupation is teaching or 0 otherwise, or 0 otherwise, or 0 otherwise. And then you are told that if the occupation is trading or 0 otherwise, or 0 otherwise, or 0 otherwise. The one that is always the or 0 otherwise, they are the ones that have not been mentioned. So it means that fishing is a 0 otherwise. But why is it not mentioned? Because anytime you are doing a dummy variable, 1 is a reference category. Ladies and gentlemen, I want to take you back to something. I want to teach you something very quickly. Okay. Dummy variables, you must have a reference category. And I want you to put that down if you have it. A reference category is always the one that is not mentioned and coded. Okay, the reference category is that particular group that every other is mentioned in relation to. It is that particular group or type which every other is mentioned, every other group is mentioned in relative to. So when I say that she is not a man, I don't have to say that, but she is a woman. So when I say she's not a man, you got to conclude the 0 otherwise. The otherwise is that she is a woman. Okay. When I say that she is not something, and you have some categories, and all of the categories. So when I say marital status, let's say I say marital status, she is not a widow, nor a divorcee, nor single. Once I say that, you know that she's what? Once I say she's not a widow, nor a divorcee, nor single, then you automatically know that she's what? She's married. That's it. So I don't have to, that's an otherwise. Okay. So every time you're doing dummy variable, there's an otherwise there. You just have to look at it. So I'm going to check whether you guys will be able to detect the otherwise. But in this very example of occupation, and take it back. In this very example of occupation, which are teaching, fishing, and trading, the reference category, the one we will mention in reference to, is the fishing, because that is the one that was encoded. Now let's look at the last one. Let me see whether you can catch that. The next one is the dominant religion. And you are told that the dominant religion are Christian, Muslims, and Buddhists. Who can tell me the zero otherwise? Looking at the next sentence. Christians, Muslims, and Buddhists. Which one is the zero otherwise? Oh, sorry, which one is a reference category? Which one is a reference category? The dominant religion. So quantity demanded depends on the dominant religion of the people. And some of the religion have been mentioned, but the one that is not mentioned is the reference category. Which one is a reference category? Beautiful. It's Buddhist. It's Buddhist. So anytime I'm talking about Christian, I'm actually talking about a Christian in relation to Buddhist. And anytime I'm talking about a Muslim, I'm talking about a Muslim in relation to what? A Buddhist. Okay. Now let's put the data together and then start analyzing the data. So this data is in Excel. So there are two things. Normally I would have done Excel, but I want to focus purely on R. I'm going to focus purely on R. So I'm going to take you to R, and then we can address it. Now, before then, somebody will have a question that we can address. In this data set, you have quantity demanded dependent on the price of the good, the complement price of the good, income of the people, the location of the shop, the occupation of the people, and the religion of the people. Now you can see that I'm using the actual English names, which makes this a dummy variable kind of data. Okay, so these are dummy variables. And what we are going to do is we're going to take this data to R, and then we'll be able to work on it. However, how do you get R? That has been the question. So how do you get R? Well, to be honest with you, getting R is a very simple thing. Okay, getting R is so simple. How do you do that? Well, all you do is go to Google. Okay, so let me take you to online here. Go to Google, and that's my Google, and just type letter R. Like that. The first thing that shows is this, which is the R project for statistical computing. Okay, so there's a software, it's a free software. Click on it. And once you click on it, you choose the latest version. At the top here, you see download, and then you click download R. It's free. You can scroll down and go to UK and choose the first one, Bristol. Okay, click on Bristol. It will take you to the exact place you have to download. And then if your computer is Windows, which most of you, your computer is, you choose what? Windows. Once you do Windows, now you choose install R for the first time. So you click, and then the latest version will come. This is the latest version, 4.1.0. Click on it and save it onto your laptop, which is what I am doing. Click and save onto your laptop. Okay. And then once it's installed on your laptop, you double click it to open and install it. It's a very simple way of installing. Done. Once you are done, go to Google again and type RStudio. RStudio. And that RStudio you're going to use, that is an interface for R. So R will be running in the background whilst you are actually working inside the RStudio. That one is also free. How do you get that? Simple. Click on RStudio, download the RStudio. Once you click on that, I'm sure you guys can see. If you can see, type yes for me, okay? Once you click on that, you scroll down, you choose the free version. Thank you, thank you, thank you. Click on the download the free version, this one. And then you click download. Once you click download, it will take you to the step 2, which you have to download. You see, it has already said install R first. You realize that, which is what we did. So you have to install R first. Then you download this R Studio and then install the R Studio. So you click that, and then you will now install the package. You put a package in your, I am just doing that. I'm just saving it into my, and then allow it to do that. Then when you finish, you install the R Studio. But look at something, ladies and gentlemen. After you install the R and the R Studio, you got to install the R first. Then you install the R Studio second. But you will never have to open the R. You have to open the R Studio. Now the R will be on your desktop, but the R Studio will kind of vanish from your desktop. So you got to look for it. So the way to get R Studio, which is what you need, is click in the search on your Windows, R Studio. The moment you start typing RS, oh, the R Studio will pop up in your applications. You may see this in my application. I don't know whether you see it, but I want to believe that you can see it. Let me see what I can show you. So this is it. You click on R2, and then it will show. Let me see what I took up. Okay, my computer is frozen. My computer is frozen, so let me see slightly. So you type R Studio. Okay. Let me see. Okay, R Studio. Just type R Studio. And then you see it popping up here. Okay. And then you click on it. You click on it. When you click on the R Studio, this pop-up will show. Let me show you. Exactly first time. That's how you see it. Okay. This is known as a console. There's an arrow on the top right here. I want to believe that you can see it. There's an arrow on the top here. Okay, this one. Okay, this kind of box, kind of maximize box. Click on that. Okay, so that's what you do. You click on that. And once you click on that, the thing will now separate into kind of 4 parts. Here, you see it in a kind of a 4 part. So one part, the part that is top left here, that part is what is known as the command window. So that's why you'll be typing your commands like that. You'll be typing all the commands like that into it. And so that's what we are going to be doing today. Okay, so I'm going to now take you back to the slides. And then we will be typing these commands quickly, and then we'll be showing some couple of results. My most important thing for now is the correlation matrix, and then a few others. But what I'm going to do now is to take you to, I don't even need to take it, I can type it here myself and then show you. I can type it myself and show you. So let's see. So let me clear all of this mumbo jumbles. Oh, very good. So the first thing, ladies and gentlemen, the first thing I'm going to do is to type a command into R and then take the data from Excel to R. Okay, so watch me. I'm going to type a command into R. So this is the R Studio. Please let me know whether you can see. So the command I'm typing is gen equal to read.delim. Okay, into bracket clipboard. Do you guys see it? If you see it, type yes. If you see what I just typed, type yes. Because I just want you to be sure that you can see it. Okay, fantastic, you can see. So now what do I mean by this? And again, all of these are in the slides, by the way. All of these are in the slide. I want to call the name of the Brukutu bitters. Brukutu bitters. Brukutu bitters. I want to call it gin. So in R, I'm giving it a name, gin. And this command on the right is going to bring the data from Excel to R. So what do? How does it work? It's a very simple thing. That's what I'm showing you. Go to Excel. So I'm now going to Excel. Look at the Excel data. Okay. So for the one I'll give it to you in your assignment, you will also have an Excel data. And then just highlight the whole thing by pressing Control A. Control A to highlight everything, Control C to copy everything. And once you copy the data, don't come and paste into R. Unfortunately, R, you don't paste things, you command the thing. See, this is where knowledge is advanced. You command, you command things. So once you come to R here, while the cursor is blinking, it's blinking anywhere on number 1. Remember, I'm typing in number 1. Okay. While the cursor is blinking, you will choose run. You see, the data you copied is already on the clipboard. So once you click run, watch down there in the console. Watch down there in the console. Nothing is in the console. And when I put a cursor on the run, it's even telling you that another way to do it is Control Enter. So once you do Control Enter, it will still be like you have done run. And once you do that, watch down there in the console. The same command in number 1 is written down in the console. Gin equal to read.delete to bracket clipboard. And the cursor straight away moves to command number 2. Now this means that your data is loaded. This means your data is loaded. Now how do you know that your data is loaded into R? Just highlight only the name, the GIN, gin. Highlight only that and do Control Enter again. And you see down there, you see the data is loaded down there. The data is loaded down there. Fantastic, fantastic, fantastic. Now that the data is loaded down there, you can now generate a correlation matrix. Okay. Now, this data, as you can see, it is having some dummy variables, location, occupation, and religion. And these dummy variables are not numbers. They are not numbers. They are not numbers. So because they are not numbers, doing a correlation with them, it will not be a smart thing to do. It will not be exact. So that is why sometimes it's good to use a coded version, the one that is 010101. Somebody says I should go over the loading of the data again. Don't worry. When you watch the video, you do it because that is not really my concern. When you watch the video again, you will see how to load the data. Loading the data is just copying it from Excel, coming to R and click run. Simple. Okay, click run. When you watch the data, you can do that because that one can take much of our time. Once you've loaded the data, you have to generate the correlation matrix. The correlation matrix. Now, how you do that correlation matrix is an important thing. Okay. Now, because and this is important, I want you to pay attention here. Because this data has the real categorical variables, I don't want it, I will do the correlation matrix, you can check it in the slides, but I want to use the Excel to do the correlation matrix. The Excel has the coded data, okay? So I've coded the data, just as we read it in the story. So you can code the data as well. So what I'm going to do is I'm going to show you the coded data in Excel. Then I'll do a quick correlation matrix in Excel for you. So look at the Excel. I have the Excel here. And what I did, and again, there's a video that shows you how to do the coding. You can see this in the YouTube channel. Okay. So what I did is at the location urban, I created a dummy for the location urban. And wherever I see urban, I call it 1. Wherever I see rural, I call it 0. It's a simple thing. And like I said, there's a video that will explain all of it. I did the same coding for occupation teaching. and I use occupation fishing as the reference category. I did the same thing for occupation, religion Muslim, and I use religion Christian and religion Muslim, and I use religion Buddhist as a reference category. So what I'm going to do is that because this one does not contain English words, I'm going to use this to do the correlation matrix. You're going to see, watch me. For the correlation matrix to be done, you click on the data tab at the top. Data tab at the top. And then go on the far right and choose data analysis, far right. Now, if you don't see data analysis, there's a video I've done on how to invoke data analysis. Okay, once you choose data analysis, in the list, look for correlation, and that's it. Look for correlation, and that's it. Look for correlation, and that's it. Double click it. And then in the first section, it says input range. Input range means you collect everything in the data, including the headings. So you highlight, drag all the information, everything from top to down. Okay. And then when you exceed it, like I've just done, you come back. Okay. And then they'll be collected into the input range. Click on labels in the first row. Labels in the first row, and click output range, and click on the white space to the right of the output range. Just go and choose any empty space. Let's say column J, first cell. Choose any empty space. That's where you want the results to be. Once you are done, watch it. You click OK, the entire correlation matrix will show. Pah! Beautiful. So you can see that the entire correlation matrix is showing. It is highlighted. They are in multiple decimal places, too many decimal places. So you can change it to just 2 decimal places. So click on the Home tab. Under the General, somewhere here, under the General, click on the little arrow under General and choose Number. Once you choose Number, everything will be converted to 2 decimal places. Just watch. Fantastic. That's what you see. So your entire correlation matrix is this. And in an exam situation, for purposes of exam, I will generate a correlation matrix, and then I'll ask you some questions on them. But in your assignment, I will expect you to generate a correlation matrix yourself using the commands I've given you in R. Okay, I'm taking you back to R. I will come back to this because you're going to answer some questions on this. Okay, let's go to R. Let's go to R. Let's go to R. So in R, I can say that I want to generate some correlation matrix. Now watch something. Watch something very carefully. But there are other things you can do before generating the correlation matrix. Okay. So you have to do those things. Let me tell you the first one, and this is important. This is important because in your assignment, I would want you to do that. The first one is summarizing the data. When you type summary into bracket, the name of the data, Jin, that will summarize the data. Look down there in the console and you see the data has been summarized. So as an example, if you are looking at it in the console, who can tell me what is the median for the price of gin? Who can type it for me? What is the median for the price of gin? What is the median for the price of gin? If you can see it in the slide. What is the median for the price? These are some of the simple questions. Excellent, you are correct. Okay, these are some of the simple questions I'll tell you. Now, this summary statistics is good, but it doesn't tell you a lot. And so what you want to do is to do a one that will give you better summary statistics. So this command. In fact, I have another video that explains all this, but I'm doing it again for you. You can watch that video and watch this again. That command is called describe command, not summary command. It's called describe. But before you can bring that command, you have to bring a certain package into R. How to bring the package into R, I've done a video on this, but I'll do it again here. The package you want to bring into R is called psych. You can see it highlighted here, psych. Psych. How do you get the package? Go to the bottom right of your page, under packages. That's why I'm clicking. Under packages. Under packages. Click that. Click that. and then choose install package. Install package, and type the name of the package, psych. The moment you even start typing psych, you see it showing. You see it gradually trying to come. And once it comes, you select and click install. That's it, finish. I have done the installation already. Okay. Once it installs, then you now type this command in number 3 here and run it. I'm going to run it. Now look down there, the results in the console. It will show blue. So once you type it, run it by clicking run or clicking Control Enter. You see, it has written blue there, which means that the package has been loaded. Now that it's been loaded, do another summary command. At this time, it's called describe. So I'm going to do describe. You see, the moment I type describe, it starts showing. Just click describe and type the gin. Now watch what is going to happen. Describe gin. Okay. Once you do gin, which is the name of our data, you run it. Look down there in the console. Beautiful description of the data has been given. Beautiful. And I mean beautiful. This is pretty. This is nice. This is wonderful. And you can see that beautifully here. This is the result. And it tells you so many things. For example, take quantity demanded like this. It gives you the number of observations, which is a sample size. It tells you the mean. Okay. It tells you the standard deviation. Let me just show you this. I like showing these things. It tells you this is a standard deviation. It shows the standard deviation. Okay. It tells you the median, the trend, the minimum absolute deviation, the minimum value, okay, the maximum value, the range, the skewness, the kurtosis, and all of that for every variable. Okay, for every variable. And sometimes some of the questions I ask you, you see it. Okay, I made Isa put some of the questions in the WhatsApp groups, and you see some of those questions. I will just ask you, tell me the mean for complement price. Okay, and you should be able to tell me. Tell me the minimum value for income, and you should be able to tell me. Oh, guys, let me trick you a little. Who can tell me the kurtosis for complement price? Who can tell me the kurtosis for complement price? Who can type the kurtosis for complement price for me here? What is a kurtosis for complement? As you can see it. Excellent. Negative 1.82. So that shows that you know what you are seeing. Excellent. Very good. Okay. So guys, for those of you who couldn't see, the kurtosis, it's not about what is kurtosis, or when you want to know what is kurtosis, Google it and know what is kurtosis, because this is not where I'll be teaching you that. But the kurtosis for complement price, this is it. This is a kurtosis for complement price. Okay. All right. Now, this descriptive statistics is very good. Now, there's something at the last one I want you to take note. The last one. You can see that they have all been given a star, 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 star. The simple answer is that because they are categorical and dummy variables. R is a very sensible package. It notices those things that are not numbers, but are categories. And it will star them for you. It will star them for you. And when it stars them, what it's trying to tell you is that do not bother about their descriptive statistics. Don't bother about their descriptive statistics. That's what it means, because they are categories. For example, you can't tell me the mean of male and female. You see, it doesn't make sense. And I understand that it doesn't make sense. Tell me the mean of single, married, divorced, and then widowed. How do you get the mean of that? So what R does is I stars these categorical variables and tells you that they are not meaningful. Okay. That's it. That's it for descriptives. That's this for summary statistics. Okay. Now, the next thing to do, and I'm doing these things gradually so that when you get assignment, you'll appreciate it. The next thing to do, and by the way, there are several other things you can do. Okay. And I'm going to do one of them. The next thing to do is to, wow, I don't have much time. is to attach the data. And this attach is going to just print the data into the memory of R. Please don't forget to detach it. Don't forget to detach it. And in the slides, when you look at the slides, I've given all of this command. I've even typed there, don't forget to detach it. Attach. You're going to attach the data because you're going to use it for just something. And we'll come back. So I'm going to command number 7 to do the thing we're going to use. We're going to do something we call the histogram. Histogram. So I'm going to just write the histogram of one of the variables, and that is kill. So look at this command, HIST histogram. Then you type kill, which is the quantity demanded. Please, when you are typing any variable, make sure that the variable is the exact name as it is in the headings. And I want the color to be yellow. So this is just a histogram of the quantity demanded, and I want the color to be yellow. Anytime you bring the hash sign, it means that anything after that is an instruction. Anything after that is an instruction. I'm going to run this, and then you see the results in the beautiful graph under plot. So watch the bottom right. I'm going to run this. Oops. Okay, so let's run this, and then you see the data as a histogram. Okay, it says that object kill is not done because I've not done attachment. So we need to run the attach first. So I run the attach, and then you run the histogram. Okay. And now you can see on the right, bottom right, a beautiful yellow color of the histogram is shown. I chose yellow. You can change the color to blue or any other color. Okay. And then you can get it in whatever color. This is a histogram of that. Now you can look at this histogram and you can see that there's in the middle version is missing. So that means that it's not normally distributed. Okay, but there's another command you can use to detect whether or not it's normally distributed. Okay. But I won't do that. I want to do another graph, and it is called kernel density plot. Again, I've explained all of this in the other video. Kernel density, but this time I'm not doing for kill, I'm doing for price. I want the color to be blue. I want the line weight to be 6. All of these are fully explained. So I want to do that. Look on the right, bottom right, and you see the results. So again, you can see the kernel density plot. Okay, that shows that the data, it appears that the data is not normally distributed. We have spoken a lot about normal distributions here. Okay. So there are several kind of plots that you can engage yourself in. There are several plots, and all of them are in the slides. I'm just picking a few of them and running them for you. All of these have already been done in the slide. This is another graph called the contact normal probability plot. Okay, and I've explained it. When the blue dots are seated on the red line, it means that the data is normally distributed. All of them are used to determine whether the data is normally distributed. But guys, determine the normality of the data is one thing, testing it is another. So this command here, Shapiro.test, okay, into bracket $kill. This command will test whether this kill variable is normally distributed. When you run it, it will give you the results down there in the console here. Anytime the p-value is 0.05 or more, then it means that that variable is normally distributed. Anytime the p-value is 0.05 or more. Now look at the p-value here. It's not 0.05 or more. But if it is 0.05 or more, then the variable kill is normally distributed. By looking at this, you can see that kill is not normally distributed. And we saw that even in the histogram. Let me take you back to a picture of the histogram. You can see that it was not normally distributed. It was normally distributed to be rising, get to the top and falling. So these are some of the things you'll be doing. Now, let me take you back to the correlation matrix. Correlation matrix. Because this very R is using the data that is not coded, is using the English data. I'm going to just remove the coded version using this command. You can check it later. And then I run the scatter plot matrix. So look on the picture on the right. This is called a scatter plot matrix, where each variable is scatter plotted. And then you can see the relationship. So as an example, watch the relationship here. Watch it. Don't get lost. Don't get lost. We have not started. The relationship between Q and M. Okay, I'm drawing it. Q and M, they will meet at this junction. And that graph, this graph will tell you about the relationship. So suppose I tell you to look at the graph and tell me the relationship. It looks like it's positive, but you might struggle to look at it. But at least it gives you a bit of a picture of the relationship. It is a correlation matrix that will give you the actual number. So let's go and do the correlation matrix. Okay. Let's go and do the correlation matrix instead of using the graphical. And I want you to know all of this. Okay. So correlation. Let's run a correlation of the entire, data. But we are removing the categorical variables for now. In the Excel, don't remove the categorical variables. So look at the results down here. Look at the results. Look at the results. Look at the results. This is a correlation matrix. Okay. Now look at the picture between Q and M. It was positive. It was positive. Okay. When you look at the graph, I want to take you back to the graph. Okay. Look at the graph here. Okay. It was kind of showing a positive relationship. Now let's come back to the result, numbers. The quantity demanded and Q. Look at it. That is the answer here. It's also positive, just as you expected. Okay. So that shows that the relationship is 0.61. So this is a correlation matrix. Now I want to take you back to your Excel. Okay. I want to take all of us back to the Excel that we did, because Excel did everything. Okay. Don't get lost. Don't get lost. It's not time to get lost yet. Okay. So this is the Excel that we did. And I'm going to ask you some questions. Some of them have been put on the page on how to answer this. So look at this Excel. This is a correlation matrix. And here you go with the questions. Look at the question. Question number 1. Question number 1. And I'll be alternating between the Excel and then these questions. Okay. Excel and this. Please let me take you back to the Excel and ask you some few things. I want you to look at the variables. Look at it. Okay. Look at them carefully. Let me zoom it. Fantastic. Remember, the variables are also, I think this is too big. All right. Now the variables in the diagonals, if you look at it, the variables in the diagonals, they are all 1, 1, 1, 1, 1, 1, 1, 1, 1. Okay, so those variables, okay, that's not our main focus. But note that the variables on the diagonals here, they are all 1, 1, 1, 1, 1, 1, 1. So that shows a perfect correlation between the variables. So suppose I ask you the first question, and that takes us to the first question, guys. Tell me which pairs of variables are perfectly correlated. Who can tell me? Which pairs of variables are perfectly correlated? You will use their correlation coefficient to determine that. Which pairs of variables are perfectly correlated? Which pairs of variables are perfectly correlated? Well, let me give you one, and I'm sure you will all be able to crack the rest. The first one is Q and Q. And the reason is that the correlation coefficient is 1. Now, who can give me another one? Which other variable is perfectly correlated? Let me take you back. I'm telling you, people are going to give me answers. Which other variable is perfectly correlated? You can type it there. Richmond, yours is wrong. Q and M is wrong. P and P is correct, Emmanuel Tego. P and P is correct because the correlation coefficient is 1. RM and RM is correct. Okay. C and C is correct. Okay. Anytime you write it, by the way, put the number into brackets and then write the number. And so when we say that a variable is perfectly correlated, what it means is that the correlation coefficient equals 1. That's it, Michelin, that's how it's supposed to be done. LU and LU. Very good. So now you understand perfect correlation. Now let me trick you whilst you are looking at the Excel. What is the correlation coefficient between RC and M? Who can tell me? What is the correlation coefficient between RC and M? What is the correlation coefficient between RC and M? You should be able to identify them easily. 0.19, excellent. Now let's go to the next one. What is the correlation coefficient between OT and RM? OT and RM. Some of you will be lost here. OT and RM. What is the correlation coefficient between OT and RM? Somebody said in his head or her head, the person said that, oh, it's vanished. It's not there. It's there. It's there because you're looking at only one angle. OT and RM. So some of you were looking at this OT and RM here. No, that won't work. Okay. But you should look at OT and RM here. That will work. Okay. So it's not all the time it's going to work in a horizontal fashion. It can also work in a vertical fashion. Excellent. Very good. Okay. So now let me ask you the next question. These are all kind of questions you get. Okay. Next question. Okay. And this is very important. Okay, Benjamin, this is critical. Which three pairs? Okay, now we've answered that question. I've asked you the question on perfectly correlated, haven't you? Okay, I asked you. So if I ask you which three pairs of variables are perfectly correlated, you can say Q and Q, LU and LU, M and M, P and P, RM and RM, and you can, any three I mentioned there. Now let me ask you, which two pairs of variables are strongly correlated with the response variable? Which two pairs of variables are strongly correlated with a response variable? Let me take you to the question. Which two pairs of variables are highly correlated with a response variable? Guys, for you to be able to answer this, you need to know what a response variable is. Who can tell me what a response variable is? What is another name for the response variable? What is another name for the response variable? This is where it gets interesting. By the way, the response variable is also called the outcome variable. So what is another name for the outcome variable? Now you got it. No, it's not independent, it's dependent variable. You can call it DV, dependent variable, DV. Independent variable is IV. So it is a dependent variable. Okay, now that you know the dependent variable, who can tell me what is a dependent variable in our case? What is a response variable in our case? What is our response variable in this story? What is a response variable? It's Q. Very good. Guys, let me tell you something. Anytime you see a correlation matrix, okay, let me show you the correlation matrix. Anytime you see a correlation matrix, the first variable in the first column is a response variable. Anytime the first variable, the one that is changing now, that is the response variable. The first variable is always the response variable. So take note. So this is a dependent variable Q. Okay. Now the question says, which variables are strongly correlated with this Q? That was a question. Now the variables that are strongly correlated with this Q are the variables that are higher in absolute terms. They are the variables that are higher in absolute terms. But the question said pairs. So pairs means that you have to mention the Q and then that variable. And then you put the coefficient into brackets. The Q and then that variable. And then you put the coefficient into brackets. So do it properly, the way some of you have written it. So which variable? What is the first one? Q and P, Mercedes. That's the best answer. Okay. It is Q and P. And I like the way you put the negative 0.87 into bracket. So the first variable that is strongly correlated with the response is this variable. Okay. It is Q and P. Q and P. Now it says two pairs. So what is the second one? What is the second one? What is the second one? Apart from Q and P, what is the second one? The second pair. Q and OTR. That's the right answer, Richmond. Q and OTR. That is the right answer. Okay. If I had said the third one, what would have been the third one? What would have been the third one? The third one would have been what? It would have been Q and LU is wrong. That would have been wrong. It is Q and RM. That would have been the correct one. Okay. Mercedes and Richmond and Michelin are answering my question. I love these people. These are my friends. These are my people. Okay. So that is how it's got to be. Okay. So that is the second important thing you should note. Now let's go to the next question. Let's go to the next question. By the way, these are the results. The next question is, which three pairs of variables are mostly multicollinear? Which three pairs of variables are mostly multicollinear? Now remember, we said that multicollinear variables are independent variables. Now look at the word, mostly means higher. So I want you to tell me three pairs of variables that are mostly multicollinear. Now remember also that multicollinear variables are independent variables. So it means that you cannot use the column for the dependent variable. Let's go to the Excel. Okay, when you go to the Excel, you are looking for coefficients that are high, independent variables. So what it means is that you don't need the dependent variable column. You don't need that. Why? Because the dependent variable is not an independent variable. Okay. So you don't need the column for the dependent variable, no. So the question is asking you that among the independent variables, now let's check here. And please, it doesn't also include the 1, 1, 1. Okay. Among the independent variables here, you're going to look for three pairs of variables that are highly multicollinear. So it becomes maybe something like W and J. Then you put into brackets the coefficient. So what is the first pair? What is the first pair of variable that is highly multicollinear? Let me see. The first pair. You said P and OTR. That's the first pair. Let's check. Okay. Is the one with the highest? Yes. P and OTR. Some of you have chosen this. P and OTR. Okay. You're saying that is the first pair. Fantastic. What is the second pair? Second pair. C and P. That is very good. The second pair is C and P. Very good. The third pair. You see, some of you are writing C and P, and some of you are writing P and C. Just be consistent. If you take the first one on the left, then take the second one on the top, then all other ones must follow that order. Okay. So what is the third pair? What is the third pair? And please, the one who wrote C and P and wrote without the minus in the bracket, you are wrong, Florette. So next time, put a bracket in the bracket. Okay, very good. Emmanuel and Florette. The third one is R, M, and M. Now you have to open your eyes and look for these things very carefully, because if you don't take it, you go and pick ones that are not supposed to be picked. You pick ones that are not supposed to be picked. So the ones that you see, these are the variables. These are the beautiful information that you are looking for. Okay. Now I could have turned the question the other way around. You see, I said most multicollinear. What if I had said least multicollinear? What would be your answer? What if I had said variables that are least multicollinear? What would be the first least multicollinear pair? Okay. You can raise your hand or you can tell me. What would have been the first least multicollinear pair? Type the answer and let me see. Least multicollinear. So that means you have to comb. You have to comb. Take your time and comb around. Because if you don't take it, you get it wrong. Excellent, Emmanuel. The first one is M and OT, this one. Okay. This one there. Okay, let me highlight that for you to see. M and OT, that's the first least multicollinear. Okay, either you take M and OT or OT and M, whichever one you go, just be consistent. The second one would have been what? The second least multicollinear. Very good. Very good. I like the answers and the contribution of Priscilla and Richmond. Richmond, that answer 0.14 is not correct. Okay. The second one, that's why I said open your eyes. See, he couldn't see it. But the second one is this 0.05. Okay, 0.05. Now let's go to the third one. The third multicollinear pair. You see somebody has gone to choose 0.19. The person is not looking deeply. Okay. Open your eyes, Ajwa. Open your eyes. The third one is LU and C. And that is 0.14 LU and C. So these are the variables that are least multicollinear. That is how you write it. Now, even though negative 0.11 here is smaller than 0.14, it cannot be part because we are talking about multicollinear pair. We're talking about multicollinear. So please note. All right. Okay. Excellent. Now let's go to the next question. Okay. Let's go to the next question. Okay. By the way, all the answers for this question are here. The next question, which three pairs of variables are least correlated? Please note, I didn't say least multicollinear. Okay. I said least correlated. Now, multicollinear deals with only independent variables. Correlated deals with any other variable, all variables. It doesn't matter whether it is dependent or independent. Okay, as long as it fits, it fits. As long as it fits. Okay. So now I want you to tell me three pairs of variables that are least correlated. This is going to be tricky. So who can give me the first pair? The first pair of variable that is least correlated. Okay, least correlated. Who can give me the first pair? The first one is M and OT. Excellent. Ima, you are following. It's still negative 0.03. Very good. Okay. Let me take you back to the Excel so that you are not lost. Okay. So the first one is negative 0.03. Okay. What is the next one? The next pair. The next pair of least correlated. Least correlated. Least correlated. What is the next pair? Next pair. You should be able to get a next pair because least correlated. The second one is 0.05. Very good. 0.05. Now the last one, least correlated. The last one. The last one is very good. Negative 0.11. Now the negative 0.11 can come into the picture because we are not talking about multicollinear. If we were talking about the multicollinear, least it would have been the 0.14. But now we are not talking about multicollinear, we are talking about correlated. And so the least is negative 0.11. Very good. Excellent. Excellent. So that is how you handle questions on correlation. That is how you handle questions on correlation. So now let's use Excel to generate regression because we've done correlation. Once again, it's a simple approach. Just go to the data tab at the top. On the far right, choose data analysis, just as we have been doing all this while. Okay, choose data analysis. Then, after choosing data analysis, look down, you see in alphabetical order, go down and you see regression, double click regression. Okay. And then the first thing you see is input Y range. Input Y range, the Y here is a dependent variable. So you're going to select everything in the dependent variable inside there. The dependent variable is kill. So you click the kill, drag it all the way to the end. Okay, which is what I've done. Then click the input X range. The input X range means all the independent variables. All the independent. So go and click the first one, which is P, drag it all the way to RM, and drag all of them down. Okay, till you get to the end. Very good. And then click labels in first row. If you want the confidence interval, you take it. I don't want it here. If you want the constant to be 0, you click it. So they wouldn't bring the constant. I want the constant. Okay, now where do you want the results to be? Click on the output range. Choose the white space to the right of the output range. And just go and select anywhere you want the results to be. I want the results to be just below the correlation matrix. So I'll select this cell. Okay, just below the RN, 2 steps below the R. Now, once you are done, if you want other things, you can bring other things like residual plots and all of those if you want to do. But all of them are not important here. So click OK, and the results will show down there, boom. Now you have your entire regression results. The results are in too many decimals. So once again, you can go to the home, choose the general, and then choose the general, and then convert the whole thing, convert the thing to 2 decimals. Okay, so that's it. You have it in 2 decimals here. So that's how you do it in Excel. You have so many things to talk about. But I'm going to do that rather in R, because doing it in R is much powerful than doing it in Excel. So let's go to the R. The R we have been dealing with all along. This is it. So I'm going to just leave one line and then do hash and type regression. Okay. Regression. You can do the simple regression first and do the multiple regression later. Okay. So I'm going to do the regression here. Now, the simple regression, there are 2 things you can do. If you have heard about regression, you can plot simple regression. So what I can do a simple regression of the Q and the P. Okay. I just did it. I typed it and ran it. Look at it on the right. You can see it. Okay. This is a simple regression. You can check it later. This time, I'm not expecting you to be able to do it easily now here. But you can easily do it if you check it later. Okay. So that's showing a quantity demanded and price. It's a negative relationship there. A simple regression. It's a drawing. Okay. And then you can, as you can see, I've done it and drawn the scatter plot. You can do that. And then I can now run a simple regression table between Q and price. This simple. Okay. Between Q and price. That's the results you see down there in the console. Simple. So you can see the only price is showing. Only price is showing. None of the other variables are showing. Okay. All right. Now you can do multiple regression, which is the most important one. Multiple regression. So the multiple regression, which is for me the most important thing, the way you do it is this. Okay, just type this command and just type gen multi. I decided to call it gen multi. You can call it anything. You can call it mlamla, momo, dede, okay, anything. Okay, you can call it gen. You can call it gen. You can call it w. Anything. I call it gen multi. Just to remind that it's a gen multiple regression. And the LM shows that it's a linear model. Q means that it's a dependent variable. That's what count says. Then you have a tilde sign, then your price, then you bring plus C, which is a complement price, plus M, which is the income, plus loc, which is the location, plus oc, which is the occupation, plus rel, which is the religion, and then you indicate the name of the data, which is gen. Then you tell R to summarize the results. I'm going to run this and look down there. Oh, mia, the results is going to show populate beautifully down there. Are you ready? Are you ready to see? Are you ready to see the results down there? There you go. The result. Now look at that. Look at that. Look at that result. Look at the results I'm highlighting. This is what is known as multiple regression results. And if it's so in an exam, I'll dump this to you in an exam and I'll ask you 12 questions. 12 questions about this in an exam. 12. It's not simple, okay? But it's very simple, very easy. And we are going to make sense of this, okay? And in order to make sense of this, I'm going to use your table. Sorry, the questions are placed in the group. Okay. So Isa, where are those questions? Where are the questions? Let's go to the group page. Isa has posted the data I'm using in the group page. He's done that for you. I'm just going to go to the group page, and then the question he posted there, I'm going to go through. Please look at the questions he posted in your group page, and you will notice that. And by the way, these questions are in the slides. Okay. I have answered already question 1 to question 5. I've answered question 1 to question 5. So I'm going to answer the next question, which is specify Brukutu Ventures regression model. Specify Brukutu Ventures regression model. Okay, that was a question. That was question 6 there. I'm going to answer that using the results you see right here on your screen. Using the results you see right here on your screen. So, and I want to show you the question also, because the question is in the slide. Let me show you the question here in the slide. So in the slide, it says specify Brukutu Ventures regression model. Okay, how do you do that? How do you specify the model? Do you guys remember that some few minutes ago, hours ago, we looked at a regression model, okay, and when we distinguish it between a regression model and an estimated equation. Do you remember? Okay. Now, a regression model, it has only the beta parameters and the names of the variables. Okay. And I told you, when you are specifying a regression model, the first thing that is supposed to come, okay, and I'm going to do an example here for you. The first thing that's supposed to come is the dependent variable. Okay, so you have to go to the results in R and look at the dependent variable. Look at the dependent variable in the R. This is it. Okay. In fact, in the R, the dependent variable is not obviously seen. It is the independent variables you see. Okay. Because when I'm actually bringing this thing into you, I will not bring the top part. I will not bring this top part. I'll just bring the coefficients down here. So the dependent variable is not obvious, but the dependent variable is in the correlation matrix. Do you remember? The correlation matrix has the dependent variable as the first column. So that is what you pick first. Okay. So what is the dependent variable here? I'm sure you all know. The dependent variable is Q. So you write Q first. I'm specifying the regression model. And then you bring equal to. Then always you bring beta naught first. Because the beta naught is the one that has no independent variable. Okay. The beta naught is the one that has no independent. It is just for cosmetics. Okay. And it has no intrinsic economic value. It has no real meaning per se. It's just to indicate what the quantity demanded in this case will be if nothing is happening. Okay. It's just for prediction purpose. For prediction. And not really for anything much. So that's what you bring. This is all knowledge you are bringing on. Then you bring plus. And once you bring plus, you go to your results. Go to the results and look at the first independent variable. Okay, that's what. By the way, the beta naught is the intercept. That's the intercept error. So the first variable is what? P. The second is C. The second is M. You're going to write them just as they are, okay? But first, you have to bring the betas in front of them. You have to bring the beta. So before the P, you have to write beta 1 P. Then you bring plus beta 2. The next variable was what? C. Then you bring plus beta 3. The next variable is what? M. Then you bring plus beta 4. The next variable is what? Location. But watch carefully how it was done in the R. And this is important. You don't want to miss anything here. Okay. How it was done in the R. They did not write location, but they wrote loc urban. You see that? Loc urban, loc urban, loc urban. Okay, so that's exactly what you're going to write, loc urban. Okay, so you go back to the thing, and then you write beta 4 loc urban. Fantastic. Then you do beta 5. The beta 5 was the occupation. but he wrote something. So again, you need to go back and look at it. Okay. Beta 5, watch how he wrote it. Awk teaching, and look at the rest. Okay. Awk teaching. So you go and write, we are specifying the regression model, beta 5, awk teaching, just as it is there. Then you do beta 6, so plus beta 6. Okay, let's do the plus here. Plus beta 6, awk trading. If you can remember, the next one was awk trading. Okay. Then plus beta 7, the other one was religion Christian. So it would be real Christian. Real Christians. And then finally plus beta 8, real Muslims. But because it is a specified regression model, what should we bring? Who can tell me? Who can type that? Because it's a specified regression model, what should we bring finally? The error. Very good. Josephine, you are with me. The error. Okay, so it's an error. So you now do plus UI. So that becomes the error. Now, this can carry a lot of weight in an exams as high as 7 marks. Now, guess what? If you miss the error term, let's say that you miss this error term, everything is 0. Everything is 0. So it's very important to recognize that when you're specifying the regression model, you have to bring along the error, the UI, error term. So this is the answer to that question. Okay, this is the answer to that question. Now, go to your page and you see that the next question is write the estimated regression equation. Write the estimated regression equation. So let me take you back to the results here. This is the R. And everything we're going to ask is based on this table. The estimated regression equation, look at this column. This column here says what? Estimate. So the thing that you just wrote, you are just going to now replace them with the numbers. Just as one of you said, now you replace them with the numerical coefficients. Okay, you replace them with the numerical coefficients. So how do you do that? Let's go to the, so please remember, we are going to write everything that we just wrote. Again, at this time, we are bringing numbers there and not beta. So anywhere we see the beta, okay, anywhere we see the beta, anywhere that we see the beta, we're going to replace them with the actual numbers, Everything else stands the same. You don't change anything except the betas, That's it. And then you know that in the estimated equation, you also don't bring the error term. So you will not bring the error term. And then, but you bring the number for the beta 8, you replace it, but you will also bring the real Muslims. So you are not changing the English words. It's the beta parameters you are replacing. And those beta parameters, what are they? They are the estimate in the regression, the coefficient, the estimate. They are the estimates, the coefficient. So let me take you back. The first thing you're going to write is the incl. Okay, let me use a different color for this. Okay. So you're going to write Q equal to, instead of the beta naught, you're going to pick the actual value. Let's go to the R. What is the actual value for the beta naught? Who can type it for me? I want to see whether somebody is with me. What will be the actual value for the beta naught? What is the actual value for the beta naught? As you can see in there. Always connect it to 2 decimal places. Okay. What is the actual value? Write some. Your colleagues are writing, you are watching. Write some. Write some. Okay, because that means that you are bringing something invisible from your cerebral cortex onto a paper. Write some. So the beta naught is the 280.25. Okay, and always keep it in 2 decimals. So let's go and then continue the write-up. So you're going to continue the write-up as 280 point, then what's the value? 0.27. Okay, 280.27. Then the next number is a minus. Okay, it's a minus. How do you know that? Well, let's go and check just for your knowledge. Okay, so these are the numbers we are getting. We are picking the numbers from the estimates here. So the next one for the P is negative 3.15. That's what you're going to do. Okay, so you now add that into your write-up. So it becomes minus 3.15 P, then minus the next one is, let me just see whether we can find the next one, because some of them you have to round up. So I want to see whether your rounding up will be good. So the next one is what? Type it there, let me see. The next one is what? The next one is what? Okay, very good. You guys are good in writing the decimals nicely. I thought somebody is going to miss that. Anyway, so it is 0.11C. Then the next one is 0.98. Okay, that's also minus 0.98 M. Okay, for the income. Then the next one, now let me take you back to the thing because you want to see what is happening. Okay, so this is it. The next one is lock urban. Lock urban. So what would that be? Lock urban, what would that be? Excellent, Florence. Okay, that is it. That is, and I like those who are following. Okay, that is minus 5.11 lock urban. That's exactly how you write it. Lock urban. Then minus, of course, if you can see, the next one is OC teaching. That is 19.43. Okay. So minus 19.43. And that is OC teaching, occupation teaching. You write it just as it's supposed to be. Okay. Then you do minus the next one. Okay. And the next one is actually OC trading, minus 46.47. Okay. Minus 46.47 rounded. Okay. Occupation trading. Occupation trading. Then minus or plus. Let me see, maybe it's plus. Okay. So you have to check every one of them. Okay. So you can see that the next one is a plus. For religion Christian is a plus. It's plus 15.55. Okay. So it won't be minus, it will be a plus. And it's important to recognize that because slightest thing you do, you lost everything. So it is plus 15.55 religion Christian. And then finally minus the last one. And the last one is religion, Muslim. So minus 23.01. Okay, minus 23.01 religion, Muslim. Okay. And that's it. You don't bring the error term. This is the estimated regression equation. That is the estimated regression equation. If you don't understand it, let me know. So that's how you do these things. Okay, that is the estimated regression equation. So you should have it so long and beautiful like that. Okay. Now, so you've been able to answer those two questions. The next one is using just the p-value. Is the estimate of the price of complement significant? Why or why not? That's what you have in your work. Okay. And again, it's scattered all over here. So using the p-value, and guys, by the way, the p-value is the last column here. Okay, that's the p-value. Using that p-value, is the estimate of the price of complement. So the price of complement, oh, what was the question? Okay. Is the estimate of complement price. Okay, good. So complement price is C. Complement price is C. So he's asking you whether C is significant. Whether C is significant. It's a very simple thing. Ladies and gentlemen, put this down. A variable is significant if its p-value is less than 5%. A variable is significant if its p-value is 5%. It's less than 5%. Okay. If its p-value is 5% or less. And the p-value is the last one. So check C. Okay. Is it significant or is not significant? Looking at the p-value is 0.008. If you are to run to 2 decimals, is 0.01. Is it significant or is not significant? Is it significant or is not significant? It's significant. That's it. Correct. Finish. Okay. So now let me go through the rest of the variables to tell me whether they are significant or not. Okay. So let's start with P. Looking at P and then its p-value. Okay. And please note the rule. Okay. The rule is that if the variable is less than, okay, that's it. Yeah, I know, it's less than 5%. Then the variable is significant. So, question, is P significant? P, is it significant? Yes. Yes or no? Significant or insignificant? You're correct. It is not significant. Let's move on. M, is this significant or insignificant? M, is this significant or insignificant? M is what? No, it's not significant. M is insignificant. M is not, because the p-value is 20%. So that's not significant at all. Let's go to location urban. Location urban, is this significant or insignificant? Location urban, is this significant or insignificant? I like the way some of you are shortening significant and insignificant, NS and all of that. I like that. So location urban is not significant. Now, occupation teaching, is this significant or insignificant? Occupation teaching. Occupation, significant or insignificant? It is significant. It is significant. It is significant. It is significant. I say it's significant. Okay. The last time somebody was saying it's significant. Say it's significant. Move on. Significant. Okay. It is significant. It is. Okay. Now, what about occupation trading? Is it significant or insignificant? Occupation trading. Is it significant or insignificant? Occupation trading. Okay, let me highlight that. Now, that p-value, if you don't take it, you will not understand what it means. Okay. But what it simply means is that there are 9 zeros before the 108. It means that there are 9 zeros before the 1. Okay. So is it significant or insignificant? It's significant. It's significant. It's significant. Religion Christian, significant or insignificant? Religion Christian, significant or insignificant? It's significant. It's significant. It's significant. Religion Muslim, is it significant or insignificant? Religion Muslim. Opele say some. Is this significant or insignificant? Religion Muslim. That's also significant. That is significant. In fact, they are all significant. That's why you see star. They are all significant at 0.1%. They are all significant at 0.1%. Let me share something with you. The star, the triple star is for 0.1%. That's what I've highlighted. The triple star is 0.1%. The double star is 1%. The double star means that it is significant at 1%. The star means that it is significant at 5%. The dot means that it is significant at 10%. So that's for your information. Okay. So now we've been able to tell that those variables that are significant and those that are not significant. Very good, very good. Now, Let's go to question 10 and 11, and we shall end at question 10 and 11. Okay. Question 10 and 11. Question 10 and 11. The first one is, question 10 says, I've answered question 9 using the p-value, which variables are significant and which are not significant. I've done that. Question 10, which is in your page, says that, is the regression model well fit? Interpret it appropriate to measure use. So this is about the fitness of the regression model. You want to take notes. We use the R squared to determine the fitness of the regression model. We use a multiple R to determine the fitness of the regression model. Okay. We use the R squared or the multiple R to determine the fitness of the regression model. Okay. So what that question is asking you the fitness of the regression model. What is that? Okay. What is that? The R squared. The R squared, by the way, when you look in the slide, in the results, okay, you see that the name is not R squared, it's actually called multiple R squared. I've highlighted it. Multiple R squared. Okay, that is what is used to determine the reliability or the fitness or the trust that one should have in the regression. Okay, the trust. The R squared measures the fraction of the total sample variation in the dependent variable. That is explained by the entire regression line. Okay. In other words, the R squared tells you the interpretation in percentage terms, the overall interpretation that this whole all these variables are explaining, the overall interpretation they are given to the dependent variable. You remember each one of them says, I can explain the dependent variable, I can explain the dependent variable, I can, okay, now when you put them together, how much explanation do they have in giving the dependent variable? That is the R squared. Okay, so the question was, and for a simple rule of thumb, my rule of thumb that I'm giving you, okay, which is from Hair and Black, is that when the R squared is bigger than 50%, it means that the regression model is well fit. That's for you. Whenever the R squared is bigger than 50%, it means that the regression model is well fit. Ladies and gentlemen, I want to ask you, is our regression model here well fit? Okay, that's the question. Is our regression model here well fit? Is our regression reliable? Using the multiple R squared, what would you say? Okay. Excellent. It is. It is. Okay. Now, how do you interpret the score now? The score that you are seeing here is 99%, isn't it? On average, it means it's 99%. How do you interpret it? How do you interpret it? What it means is that 99% of the variability in the dependent variable has been explained by all the independent variables combined. It means that 99% of the variation in the behavior of the dependent variable has been explained by the combined behavior of all the independent variables. So in other words, independent variables are trying to explain 99% of the variability in the regression line. Okay, so that is the R squared. Sometimes some authors will use adjusted R squared. The adjusted R squared simply punishes you for the inclusion of irrelevant variables into the model. So if there are some variables that are not supposed to be there, and you, like when I was talking about blood pressure and you go and mention broken heart, when broken heart is actually not a relevant variable, that will be, you'll be punished. And that punishment will be reflected in the adjusted R squared. But normally they are close. But the key point is that adjusted R squared is usually smaller than the R squared or equal to. Okay. Now, guys, I just use the R squared to explain the model. That does not fully give us a strong statistical backing, because what it was giving us was just a percentage value. It was just telling us that 99% of the variation in the dependent variable quantity demanded of gene betas, in this case, has been explained by the entire regression line. Okay, good. But is that significant? That leads us to the next question. Is that significant? That leads us to the next question, which is, the F statistic. The next question says, are the coefficients jointly significant? Are the coefficients jointly significant? We use the F test, F statistic, to determine whether the coefficients are jointly significant. So what that question is saying is that these are all the coefficients of the independent variable, all these independent variables, P, C, M, urban, occupation, teaching, occupation, trading, religion, Christian, religion, Muslim, all of these independent variables, when you put them together, are they significant in explaining the dependent variable, which the R square said we are explaining 99% of it? Is that significant? Well, to determine whether it's significant, here's a clue. The p-value of the F statistic must be less than 5%. For the variables to be jointly significant, the p-value of the F statistic must be less than 5%. So guys, when you look at the p-value, is it less than 5% or more than 5%? If it is less than 5%, it means that the variables are all jointly significant. If it is more than 5%, it means that the variables are not all jointly significant. So is it less than 5% or more than 5%? Which one? Less or more? Yes, it's less than 5%. Excellent. So it means that the variables are all jointly significant. Oh, what a day it's been. What a day it's been. It's been a wonderful time to be able to crack all of this. Okay. There are a few more questions that are there. Questions 12, 13, 14, 15, 16. So 4 more questions, okay, which we shall look at. Okay. One has to do with the variance inflation factor, which deals with multicollinearity. We'll do that. Then interpretations of individual variables, and then predictions. Okay. So we shall do that. Ladies and gentlemen, what a day it's been. What a time it's been. What a wonderful time it's been that we have been able to go through all of this incredible regression and now